Broadcast is now starting. All attendees are in listen-only mode.
All right, we're going to get started in just a minute here. Okay, let's get started. Welcome to the June Community IT Innovators webinar. Thank you for joining us for today's webinar, Encryption 101 for Nonprofits. My name is Steve Longenecker. You're used to hearing Johan Hammerstrom, our President and CEO, introduce this. I'm the Director of IT Consulting of Community IT, and I'm the guest moderator for today's webinar. Before we begin, I would like to tell you a little bit about our company. Community IT is a 100% employee-owned company. Our team of almost 40 staff is dedicated to helping nonprofit organizations advance their missions through the effective use of technology. We are technology experts, and we have been consistently named a top 200 North American managed service provider by MSP Mentor. And now it is my pleasure to introduce today's presenter, Matt Eshelman, Community IT's Chief Technology Officer. Matt?
Thanks, Steve. Thanks for being able to moderate today. Steve mentioned, my name is Matthew Eshelman, and I'm the Chief Technology Officer here at Community IT. So I've been with the company full-time for actually a little over 16 years, and during my time at Community IT, played nearly every technical role from desktop support to managing and directing our strategy related to our clients' IT infrastructure solutions and the tools that we use to manage over 4,300 endpoints at our nearly 120 nonprofit clients. So over the past several years, that work has really included a growing focus on IT security, particularly as it relates to nonprofits and their staff. So today, we are going to cover a range of topics related to encryption as part of this webinar. So we're going to start off really with an overview of encryption, and then spend the majority of our time reviewing some use cases for implementing encryption, and then wrap up our time with Q&A at the end. So as always, this session is going to be recorded and will be sent out to all the registrants, along with being posted to our YouTube channel. The slides will also be made available. So also just put a plug in for our YouTube channel, where past webinars that we have given are also available. So let's go ahead and jump in. If you have any questions, you can go ahead and use the chat feature to chat them in. Steve will be moderating that portion, and they respond to you, or go ahead and just kind of interject if we've got a relevant topic to discuss. So let's go ahead and jump right in to talking about what is encryption. So encryption kind of fundamentally, the Wikipedia definition here is the process of encoding a message or information in such a way that only authorized parties can access it, and those who are not authorized cannot. So encryption itself does not prevent interference, but denies the intelligible content to a would-be interceptor. So again, so encryption is that kind of process of encoding that message. So it's kind of helpful to look at maybe the history of encryption. So here are three examples of different, kind of from the earliest dates of encryption. So the first image, so on the left, is called a skittily. I like to say that, it rhymes with Italy, and this thing comes up in basically every kind of encryption overview webinar. So what this is, it's basically a tool that's used to perform a transposition cipher. So basically there's a baton or a cylinder in the middle, and then what would happen is that there would be a strip of parchment or leather wound around it, on which is written a message. So here you can see kind of the letters that are wound around it. So in order for this type of encryption to be meaningful, both sides have to have the same size cylinder. So you wrap the message around the cylinder, you write it out, you unravel it, you give it to the messenger can't read it because they're not sure, how these numbers relate or letters relate to each other. The recipient has the same sized cylinder as the sender. They wrap the message and then wrap the leather around it and are able to read the message. So again, this is an example, kind of an early example of encryption, and it's kind of a transposition method. So kind of from a physical space location, the message is obfuscated. So that kind of gets evolved here. In the middle, we have what's called the Great Cipher. So this was developed in 1626 by Antoine Rossignol, and so it wasn't cracked until almost 1893, so almost 1900s, about whatever 250 some years. And so this code was, the basis of the code was basically a set of 587 numbers that stood for syllables. So this is French. And so E is the most commonly used letter in French. The cipher allocated the most code numbers to writing this vowel. So, so one nomenclature, so one kind of iteration of this code, so 131 out of 711 code numbers stood for E. So basically you'd have this whole long series of numbers and a key that would correspond to a set of syllables. So that was in place for about 250 years. And then the last example here on the right is the German Enigma machine. So it's kind of was not a commercial success, but it was taken over kind of in the late or early 1900s. It was taken over and improved, and this was basically the cryptographic kind of workhorse of Nazi Germany. It was broken by a Polish mathematician, and then additional work was done during the war by Alan Turing and Gordon Welchman and others at Bletchley Park in England. And I think that was there was the movie about Alan Turing featured this kind of cracking in pretty gripping detail. So, encryption, it can be a pretty interesting and kind of sexy topic. So, so these are some examples of kind of historical examples of encryption. We'll move into some contemporary examples of encryption as we move along here. So, why in the world would anybody encrypt a message? So this result is from the 2018 Global NGO Report, which is a survey of NGOs, and as represented here, the predominant reason to protect is to protect organizational information, followed by protecting donor information, and then email and mobile. So, and I think that makes sense, and it shows where organizations are at, where it comes to think about securing their organizational data and assets. So about 41% are using encryption technology to protect their data. I would actually venture to guess that the number is probably higher just by some kind of incidental use of encryption. Kind of the things that protect us, and we aren't even really thinking about it. But again, about 41% are kind of explicitly using encryption as a way to protect their data and communications. From our perspective, there's kind of three primary reasons that would lead an organization to implement encryption, and its varied facets. So, the first one would be compliance, where you have a requirement to take that action that could be related to external factors such as HIPAA compliance or PCI compliance. So both of those standards have pretty clear statements in there that sensitive data or PII data or credit card information kind of must be encrypted if it's stored at rest, if it's stored in transit. So you may have an explicit compliance requirement to implement encryption. It may come from more of a risk management perspective, and I think that's what we saw a lot from the NGO survey, is that while maybe there's not a compliant requirement to encrypt your donor information, it's really important that you make sure that that data is really secure. And so even though maybe there's not a compliance requirement to encrypt it, we as an organization really value our information and just want to make sure that it isn't easily made public if if a laptop is lost or stolen, or if a database is hacked or something. So that it could come from just a risk management perspective in terms of an organization's perspective. So for us as a service provider, we kind of come at it from the perspective of good security practice. So we don't necessarily know an organization's risk or compliance requirements kind of initially, but we kind of see implementing encryption is an overall best practice that more and more organizations are taking advantage of, and it's actually kind of easier and easier to actually implement encryption. So again, there are kind of three dimensions to this. You may be required to implement encryption. You may do it because it's a good idea and you value security, or you may just do it as part of a good security framework that you're working through. And we view security. I've used this framework in a number of our other webinars in terms of how we view security. And so security is kind of made up of many different elements. One that's rooted in IT policy, so that kind of forms the foundation of how we make decisions about what security decisions that we're going to make. Kind of building on that is security training and awareness. Then there's kind of little blocks of good passwords and antivirus and backups and patching, and then kind of layered on top of that is encryption. So it's encryption is kind of an additive security practice. It's kind of layered on top of security approaches that are already in place at your organization. So from a structural perspective, encryption kind of covers a wide domain and is often sitting on top of an additive set of security measures. So let's take a look at kind of, okay, so we've seen some historical examples of encryption. So what does a contemporary example of encryption look like? So here, I've got the text, protect your data with encryption. And if I transform that into PGP, so PGP is a type of encryption, you can see that that text is really rendered illegible. So if I zoom in on that, yeah, it's just a bunch of gobbledygook. And so that is what somebody would see if they, intercepted a message, if they hacked onto my computer and found this encrypted file. They would just have this information that basically says, oh, this is completely illegible and doesn't serve any value to the person who intercepts the message. So that's an example of kind of a PGP encrypted message, and that would be something that would apply to a data at rest. Unfortunately, I think most of us have probably our experience with encryption is around ransomware, and so here we can see that virus writers basically figured out that they can extract value not by stealing your data necessarily, but by rendering it unusable. So in the example of ransomware, files are encrypted by the virus writer's key, and only they can unlock your files and restore the data. So again, the data is encrypted, you can't get to it, and only the kind of the person who encrypted the file can potentially decrypt it. However, in our experience, you're just better off not paying the ransom and restoring from backup. But I think that's another slide. But I think it is a good example for how we can kind of think about or understand the value of encryption. So in encryption, there's a whole kind of glossary of terms that we get into, and these are I think some really helpful ones. So there's kind of 4 top-level concepts, and these kind of intersect now as we think about where are we encrypting this data and how do we interact with certain service providers. So encrypted at rest. So again, that would be data being stored on a server is encrypted. So again, if you are saving files in OneDrive or Box or Google Drive or whatever, the data is being stored on the server in an encrypted format. So that means if somebody kind of hacks Google and takes the data, all those files are going to be encrypted, right? So that data is encrypted at rest, and so if it's stolen or taken, that data has been encrypted. There's information that is encrypted in transit. So again, that is data encrypted between the user and the server. I think the most common example would be, an SSL website. We'll talk a little bit about TLS secured email. So kind of as data is moving from one place to another, that information is encrypted. So again, this is also maybe an area where, depending, the hosting company would kind of have access to the data. So again, a service provider may be able to decrypt that information depending on the environment that you're working in. it's kind of this concept of end-to-end encryption. So again, this is typically a communication encryption where only participating parties have the key, and so you know, again, you need to be clear in terms of the service and where your concerns lie in terms of the type of encryption that you're using and kind of how these methods are you know, being implemented. So end-to-end encryption, you know, typically is used in the context of communication software like Signal or Keybase, where, you know, the message between you and the recipient is going to be completely encrypted, you know, from end to end, and nobody else can kind of see or decrypt that information. And then finally, is this concept of zero-knowledge encryption. So, you know, data is encrypted at all times, and not even the platform or the hosting company that kind of holds your data can access it. So, again, you can put anything you want on there, and the hosting company cannot see it. So, you know, in the example of Microsoft or Google or Box, like while the data is encrypted at rest, those service providers are actually providing the encryption keys to decrypt data to, you know, to kind of reveal it to you and to back it up and to kind of do all of that stuff. So the encryption key management is actually happening by the service provider. In the event of zero, or this, you know, in the example of zero knowledge, you know, that would be vendors like SpiderOak or Sync.com or Trezorit, where they're just providing you a solution, and you kind of bring your own encryption keys, and kind of all the encryption is handled by keys that you, as a consumer or business organization, maintain, which is great from a security perspective because it ensures the integrity of your data. You know, it's kind of not going to be visible. You know, for example, if you're concerned about, you know, perhaps searches or government searches and requests and things of that nature. You know, the downside is if, you know, you forget or lose your encryption key, you know, that data is gone. So, so there are some trade-offs there as it relates to managing the encryption key. So that's some of the terminology and overview, and we'll go ahead and talk a little bit about, you know, just kind of the effectiveness of it. So from, you know, a security perspective, and so this was a survey of about 510 executives at US businesses in terms of like, hey, what's going on in the world of cybersecurity? You know, you see encryption here is kind of ranked as the second most effective tool that we have as, you know, security professionals in terms of our arsenal of keeping information secure. You know, multi-factor authentication is the number one thing, and that's certainly something that we would strongly advocate for, is turning on multi-factor authentication. But after multi-factor authentication, encryption is a great way to ensure that your information is handled securely. So again, and we can see, you know, from the organization's perspective, you know, MFA and encryption are implemented and at a pretty high rate. And I think, again, this kind of shows the difference between enterprise and nonprofits. You know, there's a mandate often in you know, for-profit and publicly traded companies to implement encryption in such a way that there is not in the nonprofit sector. And so I think that's an area for us to do a little bit of catch up on. So. So this is just you know, to highlight the differences in kind of the layers of effectiveness of encryption as a solution. So let's talk a little bit about, okay, so what we encrypt. So we've had a bit of background in encryption, so from history and contemporary examples and some different terms, and so now we can spend some time again for different scenarios for what to encrypt. Again, you can chat into Steve and we'll take some Q&A questions as we go along or at the end as well. So, so there's kind of 4 top level, I don't know, domains that I've included here that we think about encrypting email. We think about chat programs. We think about full disk encryption for our devices. And then also we think about encryption within applications, so primarily databases. So that is, so that's kind of the overview. So let's talk about email, and I'll just kind of put in a plug. So I've actually gone into a kind of a lot more detail on the email encryption piece on a recent blog or kind of interview that was just published at Idealware. So you can go check that out at idealware.org/email_encryption. We'll see if I can chat that link out, but so that is, if you want to do a little bit more reading on email encryption, that is going to be available there. Oops, send that to. So we'll get to see if Steve can chat that out to everybody. And so we'll talk a little bit about email encryption. So the first one here is TLS. So TLS stands for Transport Layer Security. And so again, this is kind of coming back to that concept of saying like, hey, you're probably actually using encryption in some form and you haven't even realized it. So this actually is a example of email encryption that doesn't rely on you doing anything as the sender. So it's entirely seamless and transparent. So most large email providers, so including Gmail and Office 365, have implemented transport layer security encryption for messages in transit. So that's, from a technical perspective, this is actually an evolution of SSL. So you can think of this as kind of SSL for email. You can look it up on Wikipedia. There's a much more detailed explanation of the method if you want to geek out there a little bit. But enabling TLS or using a TLS compliant email service ensures that no one can read your email as it's in transit between another TLS compliant provider. So we used to use the analogy, and I always thought it was a great one, of basically thinking of email as a postcard. So you put your return address, where you're going to send it to, and the contents of your message. You drop it in the mailbox. The post office is going to make sure it gets delivered, but along the way, somebody could pretty easily read it. And then there was this idea of secure email or encrypted emails. You put a message in the envelope, and now you know who it was from and who it's to, but you don't actually know the contents of the message. So TLS in that regard is actually more analogous to the letter in an envelope. So the contents of the message are actually secure and cannot be read by somebody as it goes from point A to point B. So in this example here, you can see that I've received a message that was protected by TLS v1.2. Let's see if I can highlight that here. Is just, so here you see it was received, and then there's the TLS version 1.2 cipher, and that's sending a message from Gmail to Office 365. So that is a handoff that is handled securely between those two providers because they have both implemented TLS. And as an example, this is the inbound TLS report for Community IT. So this is our Office 365 TLS report. So you can see that 99% of our messages were delivered with inbound TLS v1.2, which is the most current version. We did have a very small percentage of messages that were on TLS 1.0, which is going to be deprecated. And then there's probably a message or two that was delivered without TLS. So in general, now we're seeing that most messages are going to be available or being delivered with TLS. You can go into the Office 365 Security Center to check out or verify that. I think we're a little bit high. I was looking at another client and they were kind of in the low 80s, which seems pretty high, which seems pretty good overall. And then we're also starting to see some cases where you may need to configure a specific connector to require TLS between providers. So typically for organizations that are in the HIPAA space or compliance space may need to require mandatory TLS connections to your healthcare provider or broker or something like that. So again, so TLS is kind of something that happens all in the background. It's great, and we're starting to see moves for mandatory TLS compliance come in, specifically in the HIPAA case. So moving on from kind of the transport layer to email encryption that's actually provided by the service provider. So again, this is something where you actually, as the end user, have to do something. You have to have something configured. You have to have something set up. So again, kind of moving up the stack in Office 365 with the addition of, I think it's the Azure AD Premium P1 license, which is if you have E3 or EM plus S E3, gives you this ability. If you just have the regular like Office, small bit, or the Office 365 Business Premium, it doesn't have this feature, but it will turn on email encryption within Office 365, meaning that you can send an encrypted message to a recipient. So the experience is that you would create a message. We typically would put a tag in the subject line, bracket encrypt or secure, and then Office 365 would take that message, encrypt it, and then the recipient, instead of getting the whole email, would actually just get an email with a link or an attachment said, you've received an encrypted message. Please go follow this link to read the message. And then they would click on the link and get either a one-time password or log in with their Microsoft or Office 365 account, and then be able to view that message in the window. So this is kind of helpful if you want to send somebody some secure or sensitive information and you don't necessarily want it kind of landing on their inbox and then just being available on their desktop. So, we often use it for, sending passwords or asking for sensitive information so you can reply within the browser. You're ensured that, it's only the recipient is going to be able to get to it. And so Office 365 includes this as kind of an add-on feature. Google also has the same thing. So if you're in G Suite, they have an add-in called Game, which I guess used to be Google Apps Message Encryption, but now there's G Suite, it's still Google Apps Message Encryption, Mail Encryption, but it's actually built on a third-party email encryption provider called Zix, which is here. I think, if you have any kind of online banking, Zix is a pretty popular tool for that. We use Barracuda for spam filtering, and they have an encryption add-on that's kind of rolled up into their solution. And then I know Virtue is another popular tool for kind of like a third-party encryption solution. So all of these kind of work in a similar way in that they kind of provide an encryption framework, encrypt the message, and then send the recipient a note so that they would log into a kind of a walled garden to decrypt the message and read it and kind of reply within there. So again, it's pretty easy to encrypt, and it's kind of a good next step to take if you're looking at providing maybe a higher level of security or to address a specific compliance concern. This is the step that we most often see organizations take, is like, hey, we're just going to implement this native encryption service in Office 365 or in Google or whatever, and so you can do it through here. So it's not quite as secure as kind of what we'll talk about next to the client side, because Microsoft has, kind of in the Office 365 example, both keys, and only the intended recipient is allowed to unlock the message. However, if the government subpoenaed it or something, like you may be out of luck. But in general, it's a good first step in terms of email security. So the third topic in—
Hey, Matt, if I can interrupt. Just, obviously we use this at Community IT, or I shouldn't say obviously, but we do use this at Community IT, the Office 365 version. And for people who aren't familiar with it all, I mean, it is worth kind of noting that the email is not encrypted on the sender's side. So like if I copy and paste a password that a client needs into an email, and then I send it with the tag, bracket secure information. So then the client gets that link, they log into the Office 365 world through a browser and with a key that's emailed to them, and they're in and they can see the password. But meanwhile, in my Outlook, the password remains in plain text in Outlook. I mean, I think that's obvious, but at the same time, it sort of helps people understand what's happening and what's not happening. It's the encryption happens after it leaves my Outlook and hits the Office 365 server.
Yeah, I think that's a good thing to understand. Again, as you're thinking about what type of solution you would implement or what are you trying to protect against, it's worth understanding, I think in some detail, kind of where all this data lives and how it's encrypted and where it is. So again, this kind of the client or the service provider side encryption is really great. If you want to kind of control the messaging going outbound, you're really kind of protecting against kind of the recipient kind of handling it poorly. But what you're not protecting against is yourself. So if Steve gets hacked, somebody has access to his email, that message is still going to be there, in plain text.
Yep.
Yeah, and so with that, understanding, kind of then the final type of email encryption we'll talk about is around PGP. So this is a form of encryption where it's performed on, the sender's computer, and it uses a public-private key pair to encrypt the message. So again, that was kind of the example that I showed at the very, very beginning, where the text itself in my outbox or my sent items looks like that. So it's encrypted. So if I just open up my mail, if my account is compromised, all the encrypted messages that I have are going to be unintelligible like that. They require access to my private key, which has a separate password. So in the PGP model, you've got the sender encrypting or kind of locking the contents of a message, and with the intended recipient's public key and also their own private key. So there's some fancy math that makes this all happen, but basically it means that the PGP email requires both the sender and the receiver to have PGP configured. So so both players have to kind of be on board with this system in order to receive encrypted messages, which is a little bit different than the other solutions where you can kind of receive an encrypted message, from Office 365 without kind of enrolling and generating a public key and kind of doing all this other stuff. All you need to do is, either have a Microsoft account already, or you can receive a one-time passcode, which will allow you to log in. So you can see if someone has a PGP key already by looking up at a key server. So, the universities maintain a lot of these. So if you go to https://pgp.mit.edu. So you can search for email addresses and it'll return the public key. So if you are poking around over at the MIT's PGP key server, you can see that the public key address for me, so meshelman@communityit.com, has a key ID that is 18A-DAEAB. So you can verify and you can be assured that whenever you send a PGP encrypted message, only I'm going to be able to decrypt that message. If you encrypt it and send it to me, or you misspell my name, it goes to the EL Eshelman instead of the LE Eshelman, only the correct recipient is going to be able to decrypt that message. So this, again, kind of both the sender and the receiver have PGP configured, and so this is, whereas a lot of the solutions that we've been talking about have really been focused on this kind of centralized model of control. So Office 365 is going to encrypt your messages, or Google's going to encrypt your messages. PGP is a decentralized web of trust model, which has been around for a long time, and I think continues to be a good solution, particularly in the security world. So this web of trust model where there's no central authority managing the encryption process. It's just, there's a directory that says, hey, this is a public key for Matt, here's a public key for other people, but the encryption is actually handled locally on your computer and doesn't go beyond that, or doesn't require anything beyond that. Moving beyond email into chat programs, I put this in here just because chat programs and collaboration programs have been getting a lot of buzz lately, and so the big player Slack is not on here because it doesn't implement what would be called kind of true internal encryption. So while your connection to Slack might be over SSL, so somebody sitting next to you in your office with a packet sniffer is not going to be able to read the contents of your messages. The actual contents of messages within Slack are not encrypted, so other people other than the intended recipient of the message could go ahead and read those messages. So solutions like Signal or Keybase down here are designed for security from the ground up, and so those technologies have a very high degree of security and a robust implementation of encryption. So Signal has implemented, I think it's called OpenWhisper, is the actual protocol, and so that protocol is also incorporated into the open source protocol is included into WhatsApp in terms of encryption to ensure that only the intended recipient can receive the message, so the service provider can't read your message. The same thing, iMessage actually is also considered an encrypted communication platform, and one where the service provider, Apple in this case, does not have the encryption keys to manage the server-side decryption of the messages. So again, only the intended recipient can read those messages. So again, with a lot of these solutions, while the messages themselves are encrypted, if you lose your device or your device is compromised, your messages could be read. So again, even if you're using Signal, which is kind of great from a security perspective, if you lose your device or you have weak device security and somebody gets it and is able to get on, they can still read those messages. So some of these technologies have started to incorporate disappearing messages, so that again, the entire communication or conversation thread disappears after a certain period of time. So again, somebody finds your phone or has access to your phone, they maybe don't have access to all the secret messages you've sent back and forth to the recipients. They only, maybe seeing the last day or two. So, so that's something to keep in mind. I also have Skype for Business in here. Internally, the communication is encrypted, but once messages, and this particularly as it applies to voice traffic, once it goes on the PSTN or the regular phone network, then it's kind of publicly, it can be kind of sniffed and wiretapped and kind of all that stuff. But if you're making a Skype to Skype communication, that is an encrypted channel. But if you're making a voice call to somebody on a regular phone, then that actually is a non-encrypted communication at that point. So moving on from
Matt, sorry, we had a question that I missed earlier, and I apologize for that. There was a question just to clarify in terms of the Office 365 email encryption. I know that the E3, the regular E3 license, allows that. Can you use an E1 license and then add the E3 the EM plus S to it?
Yes.
Okay.
Yeah,
so
you can add it. So yeah, so EM plus S, and we should probably do a webinar on this because there's a lot of, it's a great product, it's a great platform, but there's a lot of confusion about what it's in. And so that's actually one that they're actually overlapping SKUs in terms of what's included. So so E3 gives you Azure AD Premium P1. So that specific SKU, Azure AD Premium P1, is one of the key pieces of the EM plus S bundle. So yes, so you can do E1. So if you've got E1 for all your staff and you're just getting email and SharePoint and OneDrive and all that stuff, you're licensing Office separately, and you're like, oh, I really want to do email encryption, and I'm also interested in device security and maybe BitLocker we'll talk about. You could add on EM plus S, and so I think it's $250 a month. Then you would have that feature available.
Got it. So there's two ways to get there. And the cheapest way, if that's the only thing you want, is to stick with the E1 user license, which is free to nonprofits, but then add the EM plus, the cheapest of the EM plus S add-ons, which I think are like, what are those, $3 per?
I think it's $2.50.
$2.50 per user per month for charities. But then if you just have E3 licenses, the E3 user licenses, which are $4.50 per user per month, that would include the encryption. Yeah, got it. Thank you for clarifying that.
Yep, that's good. So it takes a while to wade through all this stuff, and things I think keep shifting and changing, especially with renaming and rebranding and that kind of thing. So great. So in terms of so now we've talked about email encryption, we talked about chat programs and collaboration tools. Now we can talk about your devices. So specifically disk encryption or full disk encryption for your Windows or Mac computers. So so full disk encryption has been around for a long time, but I would say, we're just now starting to see the adoption of this technology really increase. So full disk encryption is available for both Windows and Mac environments. So in the Windows world, the terminology, it's called BitLocker. It's available for Windows Pro and up. I think if you get home, there is some kind of encryption that's kind of available. It's can be more of a headache than it's worth. But so if you're an organization, you should be getting Pro or Windows Enterprise, and you can you can manage it discreetly. So if you just have your computer, you can just turn on BitLocker if you want. If you're an organization, you're managing, kind of any significant number of computers, I don't know, 10 or 15 or more, you can manage the encryption keys using, Microsoft provides an on-premise management utility called MBAM. I think it's Microsoft BitLocker Administration Manager. So that's a console. It includes a web page for self-service user resets or somebody forgets their encryption key. That is something that you can deploy on premise. I don't think there's any additional cost for MBAM. It's just a management capability, but that'll give you as an administrator the ability to centrally, kind of manage things and have a key. So if somebody loses theirs or forgets it or whatever, you need to get back in, you can do that. We've actually started using Intune for policy enforcement. So Intune is a component of that EM+S SKU that we talked about just a minute ago. And so that's actually pretty handy if you're in the cloud a lot, you're using Azure AD. You can enroll devices. So Windows 10 computers can get enrolled in Intune, and then you can actually set policies on them that require the users to enroll in BitLocker. So BitLocker, it's handy because then they can actually save a recovery key into their Azure Active Directory account, so you have a backup if you need it. Then it has some compliance and reporting stuff that you can do. It's pretty straightforward to implement. So we've been using that Intune for policy enforcement and key management. I think it's pretty handy. There's a couple of different ways to do encryption. So for most, for modern computers, or if you bought a computer lately, oftentimes you can select if you want a TPM. That stands for Trusted Platform Module. Maybe it's like 15 or 20 bucks. If you have a TPM chip on your computer, you can actually use that to do the encryption and not require a PIN. So if you don't have a TPM, you can still do BitLocker, but what it means is that whenever the computer restarts or reboots, the user will have to type in a PIN code, which is 4 to 20 characters long, to basically decrypt the computer so that they can then log in. So it's separate. And so organizations sometimes choose, well, hey, we're just going to make everybody type in a PIN, even though we have these chips on some computers to provide a consistent approach. Maybe you want to implement encryption, but you want to kind of stay out of your user's way. You can make sure that you're getting TPM chips as part of the computer purchase, and then it just actually makes the encryption process pretty seamless because you're just leveraging that trusted platform module to hold the encryption keys, so that the basic use scenario is like if somebody takes that computer or removes a hard drive, then they're not able to decrypt the information because that TPM chip is embedded in the device and is required to decrypt it. So so that is kind of the Windows world, which I think works well from a centrally managed perspective. Macs also include full disk encryption. I think it's called File Vault. They don't have the same kind of free out of the box management. So if you're an administrator, they don't have essentially available management console. There are a couple of third-party management utilities that allow you to manage encryption keys for Mac. We use one, the Casper suite from Jamf, to provide management, and like a whole bunch of other stuff for Macs. It's a really robust platform. I think actually McAfee has their endpoint policy orchestrator that will do encryption key management for Macs. But I think Casper's kind of the big player in the SMB space, and is a way to really provide the ability to back up and recover and help out users whenever they inevitably forget their key to unlock their hard drive. And yeah, and it really, the stuff, it's the encryption, it works. If you forget your key, you're out of luck. There's no there's no backdoor, you can't decrypt it. You're kind of out of luck. So I think it's a good decision to make, but you need to understand the ramifications and the backup plan so that you can recover information if indeed it is lost. All right, and then the final area I wanted to discuss was actually related to applications and specifically databases. So, I think most organizations in general have moved their production kind of system of record to commercial software, like Blackbaud's Razor's Edge or Salesforce or whatever, that that would include some kind of compliant solutions and the ability to have encrypted fields within the database. I'm pretty sure that some of the folks that are using, listening today, maybe have custom processes or even, kind of old custom databases that include PII information, that it's in plain text or social security numbers or credit card. So those systems that would have that information in plain text, I think, are pretty high risk. And I think it's worth understanding, kind of that risk, and then understand how we're going to address it. SQL includes the ability to encrypt columns within databases. So the technology is out there, but again, I think we need to have a good understanding of where do we have that personally identifiable information or credit card information, and kind of how are we addressing the security of that. Again, and even if you have good systems and controls in place, that may even be circumvented by, what we would see is like, oh, maybe the data is encrypted within a database, but then, somebody exports information to run a report or do something else. And so now you've got, personally identifiable information in plain text on a laptop that's not encrypted. So I think that's kind of represents the area of risk for organizations. If you, again, if you're doing healthcare, health services, you've got, you have an export of data from a secure system onto your laptop, which is which is not encrypted, and you lose your laptop. I mean, so that actually, kind of represents a reporting obligation. So we lost a laptop, had PII information on it, and we have to now notify all those people that, we lost a laptop that had their information. If your laptop is encrypted, it's like a brick. You don't have to kind of go through that same process. So again, I'm not a lawyer. You need to talk to your legal counsel for clarification on your own organizational policies. But implementing encryption, on the disk or in email and whatever, is a piece of maintaining your HIPAA or PCI compliance. So I think it's just a call again to check and understand your legacy or custom solutions to make sure that they're handling the data in a way that's appropriate and that you would expect. So I think we're kind of wrapping up the content here. So Steve, were there any more kind of comments or questions or things to clarify?
Nothing else has been chatted in that I'm aware of. And I apologize again if I missed something, but I don't think I've seen anything, and I know how to look now. I had a question as you were talking about the full disk encryption. We're familiar with the CryptoLocker type viruses where they're encrypting individual files. If I were an end user just wanted to encrypt individual files, is that something that Windows does? And is that just handled by a password? Is it as secure as full disk encryption, only just at the file level? I know that sometimes when we're doing, on the projects team, when we're doing a file server migration and we need to migrate files from one server to another, this ends up being a real roadblock to an efficient process because we run into, a folder here and there that has half a dozen encrypted files in it, and we actually can't move. We actually can't move those files, even though we have permissions to the files at the Windows level. We can't actually access the contents to move it. So anyway, I'm just curious if there was anything to think about that, or if it's just not a good idea because of that kind of a thing. It just ends up being like an administrative nightmare, and it's better to handle the full disk encryption where you have an Intune kind of platform managing it all.
Yeah. So So the first question. So BitLocker encrypts things at the volume level. So you're encrypting the whole drive. So that's kind of basically in the BitLocker boot process, what happens is, in general, your drive is encrypted. Whenever you boot up your computer and you enter in that PIN code, or you have a TPM chip, so it decrypts the volume and kind of unlocks the drive, and so then you can kind of log in and use it and access it. If somebody tries to access your volume over the network and kind of goes to browse, they will be prompted, for that BitLocker key, which they won't have. So that's kind of BitLocker is a full disk encryption. It's not necessarily encrypting each individual file. It's encrypting the volume. And yeah, so there is, for a long time there is in Windows there's the encrypted file system. So you can encrypt folders, and that may be appropriate for organizations need to store information that has credit cards or social security numbers or something like that. You may have a legitimate business need to do that. That information then should be stored on an encrypted folder within the file server. Again, it does make it more challenging, but again, the data that you have, has a liability associated with it. And I think we're becoming more aware of it. And so, yes, there may need to be a process in place to, encrypt data at rest that's sensitive, and it may make it, a little bit more complicated to do those migrations, whenever that time comes.
And I think my question elicited a good follow-up question from one of our, from the same person who asked the first question. It's a good one. Have we had any issues with BitLocker causing trouble with Windows updates?
It's a good question. And the answer is yes, kind of. So obviously, whenever you do a reboot, in the BitLocker world, especially if you're just using PIN code validation, the computer reboot process will not complete unless they've entered in, the end user has entered in their PIN code. So it could be that, the reboot process, in the non-BitLocker world, you reboot the computer, overnight, it comes back in, the end user, in the morning, they get to their login prompt, they just log in and they're in. In the BitLocker world, with Windows updates, it's updates are still going to get installed. It's going to reboot. Then whenever the end user comes in the next day, instead of the user login prompt, they're going to be at the BitLocker prompt that says, "Hey, enter your PIN code." Enter the PIN code. Then it probably is going to take a while for the the updates to finish processing, and then they're going to log in.
So the friction is on the order of like 15 minutes waiting for an update to complete, rather than it being all completely done. I mean, I'm not trying to minimize that, but that's what we're talking about. Yeah, that makes sense.
Now, the other thing that BitLocker does make more complex is updating like system drivers and particularly the BIOS. So at Community IT, for our clients, we're actually going through an automated process to update the BIOS in response to the Meltdown Inspector updates. So for computers that are encrypted, we have to basically take the step of kind of temporarily what they call disabling the key protectors, so that the BIOS can actually update the system, on reboot. So if your drive is encrypted, the BIOS update actually will not complete. So you actually have to suspend the disk encryption. So you're not actually decrypting the volume. You're kind of suspending the key protection of the volume. I know it's a kind of a nuance there, but so you can suspend that, do the BIOS update, and then it'll kind of complete as as normal, kind of the next go around. So it does again introduce some additional complexity, but it may be some complexity that you need to actually have. Great. Great. Well, thanks everybody for attending today and for the questions. I did want to highlight that next month, I think Johan will be leading our webinar that's going to be titled Building an Effective IT Function. So I'll share some of the lessons learned for us as a managed service company, managing a service desk and handling lots of support tickets and requests throughout the day. So put that on your calendar, and that will be promoted in our newsletter as well. So coming out of today, again, I just think it's worth always like having a little bit of follow-up. So I would encourage everyone to review your organization's requirements related to encryption. Do you have HIPAA compliance? Do you have PCI compliance? Do you handle sensitive information? Where do you stand? Is your organization really risk averse? Are you concerned about the sensitivity of your donor information being, compromised? And then just take some time to explore how you could use, one of the technologies here. We talked about a lot of different tools. We talked about BitLocker and FileVault for your disk encryption. We talked about email encryption. We talked about some secure communication or collaboration tools like Signal and Keybase. Explore how you could use maybe one of the technologies that we talked about today. And then, hey, maybe you can, if you're on Signal, go ahead and find a buddy and send them an encrypted message. You can find me on Signal. You can find me on Keybase. You can find my PGP ID and send me an encrypted message, and I'd be happy to help you as you explore this security frontier. So great. Thanks, everybody. And if there's no more questions, I think we can go ahead and wrap up for today.
All right, I think that's it. Thanks, Matt. I'm going to
Thank you.
stop now. Okay, bye, everybody.